Welcome to this Unreal Engine Quick Start Guide. In this guide, we'll go through some basic concepts and easy to follow step-by-step demonstrations, so by the end you should have some rudimentary understanding of the art pipeline in Unreal Engine. In this video, you'll get an overview of how to add content to your project. Learning how to import and manage assets is a crucial part of your workflow. Let's begin by taking a look at static meshes. Static meshes are the most basic form of geometry within Unreal Engine. Think of them as an all-purpose type of asset that can cover most of our world creation needs. In the realm of computer graphics, a mesh is a representation of a 3D object. It consists of three main components. Vertices are points that represent a position in 3D space. An edge is a connection between two vertices. The area formed between a closed set of 3 or 4 edges is called a face. If it has 3 edges, we refer to it as a tree, and if it has 4, as a quad. Meshes can be used to represent practically any solid object in 3-dimensional space, no matter how big or small. For that reason, you'll find that most levels built within Unreal consist primarily of static meshes. The only limitation when it comes to real-time computer graphics is the amount of faces or vertices. The greater the amount, the less performant it will be. Although the word static seems to imply that these meshes cannot move, that's not really the case. They are called static because although they can move around the world, they can't be deformed in the way that a character, for example, would deform when animated. Let's jump into Unreal Engine. To import a static mesh in Unreal Engine, just right-click in the content browser and select Import to. Once you've selected the file you wish to import, the Import Content window is displayed. Here, you'll get access to various import options, which are conveniently split in categories: General, Static Meshes, Skeletal Meshes, Animations, Materials, and Textures. First, we'll go to the Materials tab and we will uncheck the Import Materials checkbox. For now, we will just focus our attention in the Static Meshes section. Enable the Combine Static Meshes checkbox and click on Import. As you can see, a new asset appears in the content browser. Double-click on it to open the Static Mesh editor. Here, you can take a look at your static mesh. Drag and drop the static mesh to the level editor. Now you have a static mesh actor that you can move around the level and place anywhere you want. Let's import the static mesh once more, but with a slight change. Right-click again and select Import to. Select the file that contains the static mesh and make sure Import Materials is disabled. Go to the Static Meshes tab and this time uncheck Combine Static Meshes. Press Import. Instead of a single asset, several static meshes appear now on the content browser. Select the first one, and then shift-click on the last one to select everything, and drag and drop to the level editor. Seemingly, everything looks the same as before. However, each element is now an individual static mesh actor in the level, which means that you can move them independently. This could be useful in certain circumstances, but very cumbersome when you want to move the whole thing. An easy way of getting the best of both worlds is to group all these individual static meshes together. This can be achieved using blueprints. right-click on the content browser and select Blueprint class. In the Pick Parent class window, select Actor. Give it a name and double-click on it to open the Blueprint editor. Use Shift-click to select all the static meshes and drag and drop them to the Components panel of the Blueprint editor. You can select all of the individual static meshes through the list on the Components panel or by directly clicking on them in the viewport. You can also freely move them around. Press on Compile and save the blueprint. Close the editor. Drag and drop the blueprint to the level editor. You can now move the actor around the level as if it was a single combined static mesh, while still having access to the individual components from within the blueprint. Make sure you have an organized folder structure in your content browser, so all your assets can be easily found. It might not seem that important now, but it will make a big difference as your projects get bigger and more complex. A skeletal mesh is what we use in Unreal Engine for assets that require animation, such as characters, for example. Its use is not limited just to organic elements, however. Any object that requires complex animation, for example weapons, must be imported as a skeletal mesh. Skeletal meshes have two basic components. A mesh, which, like in static meshes, is used for the visual representation of the object, and a skeleton, which is made up of bones. Animations are applied to the bones, and the mesh, which is skinned to them, deforms as a result. Skeletal meshes allow for very complex and detailed animations, but in turn, working with them is a lot more involved than working with static meshes, not just within Unreal Engine, but also in the DCC app, where the asset needs to be properly rigged first. Rigging is the process of creating a skeleton for an asset and setting up any controls that might be required to animate it. Some of this work can be done in Unreal, but most of it must be done in an external app, such as Maya, 3ds Max, or Blender. Let's bring in a skeletal mesh to Unreal Engine. Right-click on the content browser and select Import to. Select the FBX file containing your skeletal mesh. The Import Content window pops up. As you can see, it's the exact same window that appears when you import a static mesh. In this case, we will turn our attention to the Skeletal Meshes section. Here we can select the elements from the skeletal mesh we want to import. The skeleton, the mesh, the skinning data, or all of the above. We can leave everything on the default settings. This time, instead of a single asset, we get three: a skeletal mesh, a skeleton, and a physics asset. Double-click on the skeletal mesh to open the skeletal mesh editor. At first glance, it looks about the same as a static mesh. On the left side though, there is a panel called Skeleton Tree. There, you can see a list with all the bones that make up the skeleton of the skeletal mesh. By selecting any of them, you can actually move and deform parts of the mesh. In a skeletal mesh, you don't directly manipulate mesh components, but the skeleton. More specifically, the bones of the skeleton. Just above the Skeleton Tree panel, there are three quick access buttons. The first one takes you to the skeleton editor. Here, you can edit and make changes to the bones of your skeleton, as well as preview animations. The third button takes you to the Physics Asset Editor. This editor allows you to create and set up the physics and collisions of your skeletal mesh. Apart from the quick access buttons, you can also access these editors by simply double-clicking in the corresponding asset in the content browser. Drag and drop the skeletal mesh to the level editor to place it in the level. Just like with static mesh components inside blueprints, a skeletal mesh can be moved around as a single entity. We will take a closer look at skeletal meshes and how to set them up in another video. Materials define the properties that determine the visual appearance of a surface, most notably the color, but also its shininess, transparency, etc. With the use of materials, you can make a mesh look like it's metallic, made of plastic or even glass. To get better control over those surface properties and get the materials to look more realistic, 2D image files called textures can be used. These textures are mapped to the surface of the 3D mesh. Physically based render engines, such as Unreal, support different workflows. Depending on the one you choose, you may typically encounter textures grouped in one of two ways. The first one, metallic roughness, which includes color or albedo, metalness, and roughness. The second one, specular glossiness, which includes diffuse, specular, and glossiness. Additionally, you may use other textures that are common on either workflow, such as normal and ambient occlusion textures. When applied to your 3D models, materials and textures allow you to render any surface type you can imagine. Depending on how you author your materials and textures, you can get anything from stunningly photorealistic results all the way to a more cartoony or stylized look. Just like with vertex count in meshes, there are limitations to the resolution of your textures, which can have a great impact on performance. Let's take a look at how all this works in Unreal Engine. Right-click and select Import to. Select the file that contains the static mesh. Go to the Materials tab and check Import Materials. Press Import. This time, not only do we get static meshes, but also materials on the content browser. We will place them on a separate folder to keep things organized. You can import materials from FBX files, but you can also create them directly in the content browser. Just right-click and select Material. Give it a name, and there you go. Now you have a material. To bring in some textures, right-click again and select Import to. Select the texture files you wish to import, and they will immediately show up in the content browser. You can open the texture editor by double-clicking in either of them. In the left side, the Details panel allows you to tweak your texture settings. Depending on the type of texture you are working with, it's important to pay attention to the compression settings drop-down menu. In most cases, Unreal Engine does an excellent job at auto-detecting the correct settings here. In this example, both the normal and color textures are correct. However, for the ORM, we must set it manually, since it failed to recognize this as a channel-packed texture. We will explore this concept more in depth in an upcoming video. Assigning textures to a material is really easy too. Open the material editor by double-clicking on the material. Drag and drop the textures from the content browser to the material graph on the material editor. Drag the texture outputs to the corresponding material inputs. In this case, the RGB output of the color texture to the base color, the RGB of the normal texture to the normal input, and for the packed texture we will use the split R, G and B outputs to the ambient occlusion, roughness and metallic inputs respectively. That's how easy it is to set up a material. Finally, I would like to take a look at a couple more concepts that are a bit outside the scope of this video. Level of detail, or LOD, is a technique used to reduce the quality or vertex count of a mesh as it gets farther away from the camera, thus increasing the rendering efficiency. This minimizes the impact of having to render hundreds, if not thousands, of objects simultaneously. This technique requires the existence of various versions of the same model, referred to as LODs, with LOD 0 being the one with the highest quality. From that point on, each subsequent LOD would have progressively fewer and fewer vertices, which makes them more performant. The engine will then take care of loading each one of these LODs at different distances, making it virtually impossible to see the degradation in quality as the object gets farther away. A similar technique to level of detail, called MIP mapping, is used for textures, where the farther away an object is, the lower the texture resolution gets. Collision detection refers to the calculations that take place to determine whether two or more objects are intersecting in 3D space, and if so, where and what happens as a result. Collision detection allows the engine to know if a bullet has made impact with a surface or if a character is standing on solid ground, for example. In order to simplify the calculations and improve efficiency, collision detection is not performed in the render mesh, that is, the mesh we actually see in camera, but on a simplified version of it, called collision mesh, that merely represents the boundaries of the object in question. Since the collision mesh is invisible at runtime, it doesn't have to look pretty. Unlike the LODs, collisions just need to be efficient geometry-wise and functional gameplay-wise. That's it for this video. Hopefully, you now have a better understanding of some of the core concepts of 3D art content creation and authoring for Unreal Engine. We simply looked at them from a very surface level. If you are interested in learning more, I would encourage you to dig into the Epic Games documentation, where you'll find much more detailed information on the topics covered here and many more. Feel free to join my Discord server as well if you have any questions. Thank you and see you soon.